Same yard, same night, same amount of bare skin on everybody, and somehow one person goes home covered in bites while everyone else barely notices. That person always seems to be the same person too. It isn't bad luck. It isn't sweet blood. Something out there is reading you, and it seems to be reading something you can't wash off. Let's get right into it. Number 9. She isn't even hungry. The mosquito that ruined your evening wasn't looking for a meal. Males don't bite, they drink nectar, and bother nobody. It's the female, and she isn't feeding herself. She needs what's in your blood to build a batch of eggs. Your blood isn't dinner. It's closer to building material. That changes what she is. A hungry animal grabs whatever's nearby. She's running a supply job, and she has a favorite supplier. Aedes aegypti, the species behind dengue, yellow fever, and Zika, has specialized so heavily in people that our scent seems to be the most interesting thing in its world. There are other warm bodies around. The dog, the neighbor's chickens. She goes past them to get to you. So her first question is easy. Where are the humans? Her second question is what this whole video's about. Which human? Because that's the part that feels personal. Same air, same darkness, bare ankles everywhere, and one person gets destroyed while everyone else says, "Hey, not bad tonight." She seems to be choosing. So how does something that small run a selection process on a group of adults in the dark? It starts with the one thing you can't stop doing. Number 8, your breath is a light switch. Every time you breathe out, you leave a trail of carbon dioxide drifting downwind. Mosquitoes pick it up with sensors near their mouth parts, and estimates of the range vary a lot, but a female can catch a human trail from across a yard. Holding your breath won't help. Caltech researchers pointed out the obvious flaw. The person next to you is still breathing, and their trail leads right into the group. Here's the interesting part, though. Carbon dioxide doesn't identify you. Everyone out there is breathing. Every mammal in the neighborhood is breathing. What it seems to do instead is flip a switch. In one experiment, mosquitoes were shown colored dots and ignored them completely, until researchers puffed carbon dioxide into the chamber. Suddenly, the same dots mattered. A separate team found something similar with body heat. On its own, it did almost nothing, and only seemed to help alongside carbon dioxide and human smell. So your breath probably isn't what picks you. It's the alarm that wakes up everything else she's carrying. Which leads somewhere slightly unsettling. When a mosquito's eyes come online, what is she looking for? Number 7, she sees in red. Mosquito eyesight got written off for years as too crude to matter. Then a team at the University of Washington put them in a chamber with colored dots and tracked over 1 million flight paths. After a puff of carbon dioxide, the mosquitoes went for red, orange, black, and cyan, and ignored green, blue, purple, and white almost entirely. Find you think, wear a white shirt. Here's the line that spoils it. Human skin, whatever its pigmentation, gives off a strong signal in that same red-orange range. The exact band she's just been switched on to look for is the band we broadcast by default. So pale clothing might make you a slightly duller target. Your face, neck, forearms, and ankles keep transmitting regardless. And that's still only mid-range. Mosquito vision is genuinely poor, useful over a few meters at best, and a gust of wind or a host who moves can throw the whole approach off. Which left the final stretch unexplained, the part where she closes in on one specific patch of skin. For over a century of research, nobody had a good answer. Until 2024. Number 6, the heat vision discovery. Everyone assumed we understood how a mosquito senses your warmth. Up close, she can feel heat rising off your skin, and once she lands, she can read your temperature by touch. Both are useless at range because a light breeze scatters warm air. So a team at UC Santa Barbara asked whether mosquitoes could do what pit vipers do, sense thermal infrared, the radiation that carries heat across open space. They built a cage with 2 zones filled both with human odor and carbon dioxide, and exposed only one to infrared from a source at roughly skin temperature, with a barrier blocking any heat arriving through the air. Adding that, infrared doubled host-seeking activity out to around 70 centimeters. They traced the sensor to structures at the tips of the antennae, and the finding was published in Nature. It also backs up something people worked out long ago. Loose clothing tends to be tight clothing, partly because the gap lets that heat scatter before she can read it. But notice the problem stacking up. Everyone's skin sits around the same temperature. Everyone reflects red-orange. Everyone breathes. Every cue so far only announces human present. None of it explains a choice. That answer wasn't in physics. Number 5, Subject 33. In a lab in New York, there is a person known only as Subject 33. Researchers at Rockefeller University had volunteers wear nylon stockings over their forearms 6 hours a day, on and off across 3 years. Then they ran every stocking against every other one and let mosquitoes pick a tube. Subject 33 came out roughly 4 times more attractive than the runner-up, and about 100 times more attractive than the least appealing volunteer. Not 30% more, around 100 times. The samples were anonymized, so nobody knew whose stocking was in the box. It didn't matter. The team could tell within seconds because the insects would swarm that tube. When they looked at what set the popular volunteers apart, one family of chemicals stood out: carboxylic acids sitting in sebum, the oily film on your skin. A second round with over 50 new people put subject 33 straight back on top. And here's the part that should bother you. Some volunteers stayed in the study for years. Their habits changed. Their diets changed. The magnets stayed magnets. The researchers called it a very stable property of the person. Which raises an obvious question. Those chemicals sit in skin oil. Something has to turn oil into a smell. Probably not you. Number 4, it's not you, it's your bacteria. Strictly speaking, you don't smell like much on your own. Fresh sweat is basically odorless. The smell everyone recognizes gets manufactured by microbes living on your skin, feeding on what your body puts out. Your body odor isn't really yours. It's exhaust from a city of bacteria built on your surface. So the mosquito may not be judging you at all. She's judging your tenants. A team at Wageningen University found that people highly attractive to the African malaria mosquito tended to carry more bacteria on their skin, but fewer different species. The less appealing volunteers hosted more varied communities, and the researchers suspected some of those extra species might be muddying the signal. That part is still a suggestion. Nowhere is this clearer than your feet. Researcher Bart Knowles once set his worn socks on top of a mosquito cage and watched the insects go wild. That led to the experiment that won him an Ig Nobel Prize in 2006, showing the female malaria mosquito is drawn to Limburger cheese about as much as to human feet. Funny for about 4 seconds. Then you learn why it might work. The bacteria giving those cheeses their aroma are relatives of the ones living on human skin. So washing harder probably isn't the fix, which leaves the layer underneath. Number 3, you were born this way. Every summer the internet hands you the same list. Blood type, blood sugar, garlic, bananas. The Rockefeller team's verdict on most of it is short. There isn't much credible data behind it. Blood type is the one people defend hardest, so let's be fair. One study did find blood group O subjects attracted more Asian tiger mosquitoes than other groups, though the gap was only clearly significant against group A. But researchers reviewing this literature describe the data as contradictory. Some studies see something, others don't. Here's what holds up better. A team at the London School of Hygiene and Tropical Medicine tested 18 identical and 19 non-identical twin pairs, having them put their hands into a tube of mosquitoes. Identical twins matched each other closely in how attractive they were. Non-identical twins matched noticeably less. The authors were careful about it. Small sample, and they called it a pilot study, but it points to the same direction as everything else. The oil is yours, the bacteria are yours, and the settings for both look like something you inherited rather than something you chose. So you probably can't diet your way out of this. You can, however, get worse at it overnight. Number 2, the upgrades you didn't choose. Your baseline looks fixed, your current setting isn't. In the Gambia, researchers compared pregnant and non-pregnant women sleeping alone in identical huts. The pregnant women attracted about twice as many malaria mosquitoes. Part of the explanation is dull and mechanical. Late pregnancy means breathing out noticeably more carbon dioxide. A follow-up under bed nets found mosquitoes getting in more often over the pregnant women, who took a clear majority of the bites. Which means the group already most at risk from malaria is also the group getting targeted hardest. That's not a fun fact, that's a public health problem. Then there's the one you'll actually relate to. In Burkina Faso, volunteers became measurably more attractive to mosquitoes after drinking beer. A control group on water didn't change. Why? The authors suggested that processing alcohol shifts something in your breath and odor, and openly admitted they had no direct evidence for it. So pregnancy turns the dial up, a beer turns the dial up, both wear off. But one thing can rewrite your scent from the inside. And not by accident. Number 1, the parasite rewrites your scent. In Western Kenya, researchers put together 12 groups of 3 children. In each group, 1 was uninfected, 1 carried a stage of the malaria parasite that can't be passed on, and 1 carried gametocytes, the stage that can survive inside a mosquito and spread. Then they let each child's body odor drift toward a chamber of mosquitoes. The children carrying gametocytes pulled in about twice as many as the other 2. You could argue those kids were just naturally appealing hosts. The researchers thought so too. They treated the children, cleared the parasites, and ran it again. The difference disappeared. 3 of the 4 human studies since have pointed the same way. And the effect seems to track with how much of the transmissible stage a child is carrying, meaning attraction may peak right when spreading is most likely to work. Nobody has fully nailed the mechanism. One leading idea is that infection shifts the skin's chemistry, possibly through those same skin microbes. Strong pattern, unfinished explanation. But sit with the shape of it. A parasite in a child's blood, apparently adjusting how that child smells in a way that brings the insect carrying it closer. The WHO estimated 610,000 malaria deaths in 2024, about 95% in the African region, and roughly 3/4 of those among children under 5. And when Rockefeller engineered mosquitoes missing whole classes of odor receptors, hoping to build one that couldn't find us, the mutants still found us, and could still tell a magnet from a low attractor. As one researcher put it, she has a backup plan, and a backup plan, and a backup plan. So here's what this was actually about. You were probably never bitten at random, and you were never being punished for something you ate. You're being read. Chemistry you inherited turned into a smell by bacteria you host, broadcast in a band you can't switch off. For most of us, that's a ruined evening and an ankle we shouldn't scratch. For a lot of the world, it means being easy to find. And in the worst version, the thing writing your signature is already inside you. That's all for today. I'll be making similar videos in the future. Subscribe to see them.